Okay, so Jean says for number 10, there is a video explaining how to solve it. How do I miss those videos? Thanks. Okay. Could you go over number 9, section 8.1? Can you go over the quiz format? Do we still upload our work? Okay, I'll take homework questions at the end of the class just to make sure we have enough time. Yeah, I'll go over the quiz format. You do not upload your work tomorrow. Tomorrow is just a multiple choice quiz. Okay, it's still through Proctorio in Canvas. Do you get multiple tries? No, you do not get multiple tries, unfortunately. Not on the multiple choice test. Take home something? I don't remember take home anything. So, so yeah, tomorrow will be a quiz. That's the only thing that we're doing tomorrow is taking the quiz. It will be, it's a multiple choice quiz. It's still 3 hours, yes. I think for 2 hours and 50 minutes. Go here, share my screen. Actually, how long should it take? How long, that's a great question. How long should it take? It's 10 questions, multiple choice. I would say maybe 10 minutes a question. So what's that? 10 times 10 is 100 minutes. So what's 100 minutes? Well, that's at the very max. So do you get multiple choice? No, you do not get multiple choice. It's multiple choice. You get to choose out of 4 responses. That's what you get. Okay. The answers are there. You just have to tell me which one it is. So it's just the quiz tomorrow, no lecture, correct. If you have issues taking the quiz, you can always pop in here. I'll be working on other stuff. Probably preparing for chapter 11 lecture the next day, but I have them all written out. I just have to remind myself of what to cover. Is the quiz less weighted than the exams in our grade? Yes, it's half as much as a test score. It's half a test. The other ones are, the other ones are 100 points and the quiz is 50 points because it only covers 4 sections. Section 8.1, 8.2, 10.3, and 10.4. And it's basically on arc length and polar coordinates. Okay, arc length and surface area and polar coordinates. We'll be going over polar coordinates today. Okay. Let's go here. What's this that I don't need? Sure. see. Who's that handsome man? Okay. Okay, so yeah, quiz is chapter 8 and 10 quiz. This one again is, it's a graded quiz. It's remotely proctored by Proctorio. Make sure that you have, that you're working in Chrome and you have this little Proctorio shield up, okay? You will not be uploading any of your work. You'll merely be choosing the correct answer, okay? So, oops, don't want to show the questions. Let's see. Edit. Okay, it's a graded quiz. It's worth 50 points. Okay, it will be available from tomorrow at 2:30 to 5:30. Okay, assigned to everyone. Make sure that you have Proctorio, graded quiz. Okay, it's 10 questions, multiple choice. Proctorio settings. Okay, record video, audio, record screen, record web traffic. Okay, video, audio, desktop, ID check. You can have the scientific calculator and the basic web tools. Behavior settings is custom. Computer abnormalities, navigating away. Weird keystrokes, copying and pasting. Okay, environmental abnormalities, audio levels, multi-face, exam duration, start times, end times, exam collusion. That's about it. Okay, so pretty standard. That's it. Correct. The quiz is in web. The quiz is on Canvas. Correct. The quiz is on Canvas, not WebAssign. It's multiple choice on Canvas under quizzes. So let's go to the quizzes tab. There's the quizzes tab. There's the quizzes tab, and it says, "Oh, look at the quiz here," and it's boom. Okay, chapters 8 to 10 quiz. Okay, and I'll bring up the quiz for you. And each question is worth 5 points. Let's find the length of the curve. Woo. Okay. So, and then it has multiple choice answers. Look at those multiple choice answers. Aren't those beautiful? Boom. Okay. There we go. That's it. That's all you get. Okay. Okay, let's go over today's notes. Okay, 10.3 and 10.4. Okay. So hopefully you're able to cover arc length, okay? Okay, we're gonna do a little bit of that later on here. Okay, so let's go over. Oh, let me share my screen real quick. I'm not sharing my screen. Okay, let's go over 10.3 and 10.4. Okay, 10.3 is on polar coordinates. Okay, and so polar coordinates are a way to write a point, okay, using trigonometry, using a circular frame of reference. Okay, and so say that we had 1 here. Okay, this would be a circle of radius 1. Okay, and so a point on this, okay, a point on that circle could be referenced by the radius or the length from the origin. So we'd say that this is radius 1, and then the angle theta that it creates with respect to the x-axis, right? So the angle here would be pi over 4. Okay, so we say this is r theta, okay, as opposed to xy. Okay, so xy, this would be radical 2 over 2. Radical 2 over 2. Okay, how do I know that? Because it's on the unit circle. Okay, and it's just the cosine of pi over 4 is radical 2 over 2, and the sine of pi over 4 is radical 2 over 2. And so that leads us to writing these things or converting them. If I need to convert from polar to rectangular, I could just use sines and cosines. I could say, oh, this is r cosine theta, and y is r sine theta. Okay, so this is to go from polar coordinates back to rectangular coordinates. What we call the x and y's, we call them rectangular coordinates. Okay, now what if we wanted to go the other way around? How would we find r and theta if we were just given an x and a y value? Well, we would use the Pythagorean theorem. We'd say, well, r is equal to the square root of x squared plus y squared. Okay, so r is equal to the square root of x squared plus y squared. Okay, we could do a plus or minus here as well, because r can be negative. We'll talk about what that means in a little bit. What it means for r to be negative. Okay, so that's r. If you give me an x and y, I can figure out what r is. Okay. Okay, and what about theta? How would I find theta? Well, theta is going to be the tangent of theta is going to be y over x. The tangent of theta is y over x. It's the height over the width, okay, of this little triangle in here. I'll just be like, oh, there's a point out in space, right? And this is r, right? And this is theta. Then this would be x, and this would be y, right? So this would be x, and this would be y. Okay, this would be a right triangle, and so if I take the tangent of theta, that would be y over x. And so we would say that then the theta is going to be the inverse tangent of y over x. Okay. Okay. Sounds good. Okay. And this is how I would go from rectangular to polar coordinates. Okay. So This would give me, at the end, I would end up with r theta. This would give me, at the end, maybe I'll put it underneath here. This would give me an r into theta. If you give me x, y, I can go to r theta. Here, if you give me r theta, I can go to x, y. And hopefully many of you covered this in pre-cal at some point. Okay, it's not a completely new concept to you. If it is, it's fine. You're not too handicapped, because we won't be doing anything too extensive with these things. Okay, number one. Let's sketch a polar graph. Sketch the polar curve r equals 2 times the cosine of theta, and find the Cartesian, that's rectangular. Another word for rectangular is Cartesian. Okay, xy equation, okay, of the curve. Okay, let's sketch the polar curve r equals 2 cosine theta, and then find out what this looks like. Okay, and then we're gonna write the find the equation in regular xy variables. Okay, so let's look at theta here. Okay, so theta. Okay, let's do this in stages. Let's build up to our 2 cosine theta. So here we have cosine theta, and then we have 2 cosine theta, which is what r is, right? So that's r. R is equal to 2 cosine theta. And so then this will give me, for any value of theta, this will give me an r value and a theta value, okay, r theta, and that will give me my point. Okay, so we know that we're taking the cosine of things, so let's take the cosine of nice things to start off with. Okay, let's say that we do 0 as our initial angle. Then the cosine of 0 is 1, and 2 times 1 is 2, and so this becomes r, which is equal to 2. Remember, this column is r. That's the r column now. Why? Because r is equal to 2 cosine theta. So this is going to be 2, r is 2, and theta is 0. Oops. Theta is 0. Boom. Okay, let's move up to, say, pi over 4. What would pi over 4 be? Okay, pi over 4 would be, should we do pi over 4? Yeah, that's fine. Okay, pi over 4. What's the cosine of pi over 4? That's radical 2 over 2. And so what's r? R is radical 2, and pi over 4 is my angle. Okay, what about pi over 2? Pi over 2, well, cosine of pi over 2 is 0. 2 times 0 is 0, and so this is 0 for r, and the angle that I started with was pi over 2. Okay, let's try 3 pi over 4. Let's try 3 pi over 4. Let's see what happens here. 3 pi over 4 is going to be the cosine of 3 pi over 4. That's x is in the second quadrant, right? So that's in the second quadrant, which is negative x. Cosine is x value. So this is going to be a negative radical 2 over 2. Okay, 2 times that just cancels out the 2. We'll get negative radical 2. And so this is negative radical 2 and 3 pi over 4. We'll talk about what it means to have a negative r. Negative r, what does that mean when r is negative? Okay, and then let's look at pi here, pi. And pi, we're going to plug in pi. Cosine of pi is negative 1, right? Is negative 1. Negative 1. Okay, and then Okay. We get -1, and then this is going to be -2, and so we get -2 comma pi. Interesting. Okay, and then I'm gonna stop there, and then I'm gonna start trying to sketch this thing out. Okay, I might try a couple other values just to get kind of a good start on this, but I'll put the graph over here. It's radius and angle. Stop, go away. Okay, it's radius and angles. So the angle that I'm looking at, right? The angle theta, okay, going clockwise. Okay, we're gonna start at an angle of 0, but then end up at a radius of 2. Okay, so that's gonna be 1, 2 here. Okay, maybe I'll use a different color. Okay, so I'm gonna put a dot there at 2, 0. Okay, this says that at pi/4, that's a 45-degree angle. At pi/4, I'm at radical 2. So I'm at radical 2. Radical 2 is about 1.41. So I'm almost at 1.5. Okay, maybe we'll just eyeball it to here. Okay, and we'll kind of see like it actually should be here. Sorry, should be right there. Okay, because what do I know about radical 2? Radical 2 is the hypotenuse of a 1/1 triangle. If I did 1 squared plus 1 squared, I get 2, and then take the square root of that, I get radical 2. So this is actually the hypotenuse of this 1/1 square here, right? It's the diagonal of a 1/1 square, or the hypotenuse of a 1/1 triangle. That's what I should say. Okay, so that's radical 2. That's another point, okay, on there. And then what about the next one? This is at pi/2, I'm at 0. The radius is 0 at pi/2. So think of it like I'm going this direction with the green arrow, but the radius is 0. So I'm really just at the origin. So I start here. Maybe I'll label these 1, 2, 3, right? It gives me a direction. I start here, but I'm going from 1 to 0, or to 2 to 3. Okay, and let's see what happens when we go to the next one here, 4. Okay, what is this guy? This guy is negative. Well, he's in the 3 pi/4 direction. That 3 is not going to be really happy here. Let's do 3 over here. Okay, it's in the 3 pi/4 direction. So let me draw that. Okay, and again, it's radical 2. So it is this whole radical 2 thing. We did 1, 1. Okay. Okay, it should be about here. The only problem is that it's a negative. So what does the negative tell me? The negative tells me that instead of going in the direction of the angle, I'm going in the opposite direction. So it's actually down here. Okay, that's a negative r. Okay, negative r, what does a negative r mean? It means, what was a negative r? Oh, it was up here. Okay, it means that we go in the opposite direction, opposite angular direction. Okay, so we're, instead of going in this direction, okay, which is what we could have gone, instead of going this direction, we go the opposite. The angle is 3 pi/4, right? The angle is 2 pi/4, but the radius is negative, so we end up actually going in, end up in the same spot, but in the opposite direction. Okay, and it's looking like we're getting like the vertices of a square here. We're really not. But when we do the next one here, it says, well, we're out at pi. We're out at pi, and then we're out at -2. So instead of being out +2, I'm at -2, and so I'm back to where I started from. So it seems to be oscillating through these values. Now, if I did a couple more values here, maybe I'll change the color here on this. If I did a couple more values, I'll call this 4, whoops. Call this 4 and 5. 1 and 5 are the same. Okay, if I took a couple more values, maybe in between 1 and 2. Well, what's in between 1 and 2? That's that we know on the unit circle. How about pi over 6? Okay, so what's the cosine of pi over 6? The cosine of pi over 6, that's radical 3 over 2, right? And so then multiply that by 2, we get radical 3 this time. Radical 3 is about 1.79. So we're going to have a pi over 6, okay, or a 30-degree angle, and it's about 1.79. It's basically it's a ratio of 1 to 3 in the height and the height and the width. But what we would get is we would get right here about, okay? We get there, this would be for pi over 6. Okay, and then what about pi over 3? What about 60 degrees? Pi over 3. So this would be radical 3 pi over 6. Okay, and what about pi over 3? We're going to get the cosine of pi over 3 is 1/2. Okay, 2 times 1/2 is just 1. So this is going to be 1 and pi over 3. That's kind of interesting. Is it 1? No, that doesn't make any sense. Let me see. Oh yeah, it is 1 because it is at 2. What did I mess up on this guy? Radical 2? Nope. No, because it goes 0 at pi over 3. And pi over 3, it should be, think about this again. Pi over 3 is 1/2. Cosine is 1/2. That's the x direction, yes. And then that's, so r should be 1 pi over 3. So let's see what we get here. Okay, so 1, yeah, 1 pi over 3. Okay, so what are we going to get? So that's 1, that's radical. Oh, r is 1. Yeah, r is 1. So it's less than, it's about right here. And then, yeah, that makes sense. And right there. Okay, so when I look at all these points, what I'm really getting is I'm getting a circle that is centered. It's kind of getting a little busy here. But if I just, oops, let's put that back. Okay, and if I just focus on the points that I've drawn, I'm just going to focus on, I'm going to highlight these points. Point there, a 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 point there. And if I draw a curve that were to cover all of the points, okay, that curve is a circle, perfect circle. Okay, and it's a perfect circle centered at 1, 0. So the center is at 0, 1 with a radius 1. Okay, radius is 1. Centered at, sorry, 1, 0. My bad. 1, 0 with radius 1. So that's what we're getting. Now we can prove this by changing this into a rectangular equation. So we have r is equal to 2 cosine of theta, right? 2 cosine of theta. Okay, so this means, okay, what is cosine of theta? Well, x was equal to r cosine theta, right? So x is equal to r cosine theta. That's how we would change r theta into xy, right? Okay. So wouldn't you agree that x over r is equal to cosine of theta, right? So let's just plug this in. Let's plug in x over r for cosine theta here. I'm going to go r equals 2, okay, 2x over r, right? Okay. And then I'm going to multiply both sides by r. And now we get r squared equals 2x. Okay. But what was r squared? Well, using the Pythagorean theorem, it's x squared plus y squared. That's what r squared is. R squared is x squared plus y squared. That equals 2x. So I'm going to subtract the x from both sides. X squared minus 2x is equal to y squared, and then I'm going to complete the square on this. Okay, I'm going to go x squared minus 2x plus 1 is equal to y squared plus 1. Okay. Do I want the y squared should be minus y squared equals 0. Equals 0. Let's just do that for right now. Okay. No, it should be plus. I'm sorry. It should be plus y squared. And then I'll just let this be equal to 1. Okay. I didn't want to move the y squared to the other side. Okay, so let's factor this guy. This guy gets factored in x minus 1 squared plus y squared equals 1. And what is this? This is the equation of a circle, okay, of radius 1 centered at 1, 0. So it does make sense to our graph, what we graphed here for our, oops. Okay, for our polar equation. Okay, let's do one more of these. Okay, let's do one more of these. Okay. Let's do something called a cardioid. Okay, number 2, sketch. R equals 1 plus the sine of theta. Okay, R equals 1 plus the sine of theta. Okay. And by the way, if you want to see how these are done a little bit nicer, you can always sketch them on Desmos. Desmos will sketch polar coordinates. Graphing calculator. Okay, it's a free online calculator or a free online graphing tool. Okay, and say that I want to graph. Okay, R equals, what was it, 2 cosine theta in the last one? Okay, so okay. Get all my, okay. So the first thing I notice is I have a Cartesian coordinate system here. That's fine. I'll change the coordinate system. I'm going to go to the little wrench here. I'm going to change the graph settings, okay, to be polar. It says grid here. Go away. It says grid, and then it has rectangular grid or it has polar grid, and here's a polar grid. Okay, again, it doesn't change the location of the points. Okay, it just changes how they're being referenced. Okay, for example, the point 1, 0, it's still 1, 0. Okay, regardless of which grid you're using. Okay, I'll plug that and I'll show you. Okay, 1, 0, 0, boom, on this thing. Here's my parentheses. Okay, again, I can change this from polar coordinate system, polar reference system, back to a grid reference system, and it doesn't change. The point does not change there. Okay, location of the point. It's just how we're referencing it. Okay, so let's go back to our polar. Okay, our polar coordinate system. Okay. And say I wanted to plug in, okay, R equals, okay, not plus, equals, come on, go back, equals 2 cosine theta. Now cosine is a function, and so it asks me and says, well, here's your functions, and I can do a cos. I could also just type in CLS. And then it says theta, right? I want my theta. Well, that's a Greek letter. So where my theta is in my keyboard here. And so I just do my theta, and lo and behold, it comes up with my circle, okay, centered at 1, 0, okay. And they tell you, okay, well, where do you want to go? We want to go from 0 to pi, 0 to 2 pi. If we went 0 to 2 pi, we would just go around the circle twice, okay. The way it works, okay, because we would start tracing these out, right, and then we would go negative here, with our R's, and we would trace this out in the second quadrant. Once I got to the third quadrant, I would start tracing portion out again, the top half out again. And then when I get to the fourth quadrant, so in 2 pi, you would actually do 2 cycles of this circle of radius 2. Okay, so if I wanted to do the cardioid, okay, R equals, where's my equals? On the keyboard, I guess. R equals, and I'm going to do 1 plus the sine of theta plus the sine of theta. Go to my functions key, hit the sine of, and then grab my theta here, my angle, okay, and it is called a cardioid. It's supposed to look like a heart. It doesn't really look like a heart to me. It looks more like, I don't know. You come up with something, but it is a cardioid. Okay, it's just 1 plus sine theta. Okay, it's an upside down heart, according to mathematicians. Okay, and so let's plot one, and then this goes from 0 to 2 pi. That's fine. There's not 2 cycles here. There's only 1 cycle. Okay, if I were to try to plot a point here, well, you could see, okay, that at 0, okay, let's plot a point. Okay, let's plot a point. When the angle is 0, then R is 1. Okay, so you can see that 0, 1. So let's plot the point 1, 0. Okay, and then we'll plot some other interesting points too in a minute. Let's go back. There we go. Go back. I don't need your editing tips. Thank you. Okay, so if we go 1, 0, 1, 0, stop with your editing tips. I don't care about your editing tips. Okay, 1, 0, there's a point there. If I want to do it in polar coordinates, as long as I use an angle, it should understand that I'm going to use polar coordinates. So let's say that we want to do a pi over 4. At pi over 4, we want this value here. So what would be the value at pi over 4? Well, it'd be 1 plus the sine of pi over 4. Well, what's the sine of pi over 4? It's radical 2 over 2, right? So what's 1 plus the radical 2 over 2? Well, it's 1 plus radical 2 over 2. So, so that would be the angle. R would be 1, radical 2 over 2 is about 0.707, so this is about 1.707, and the angle, okay, so let's do 1 plus the square root of 2, okay, divided by 2, okay, comma, and then pi over 4, so go to ABC to get my pi, I believe. You can just type in pi too, pi, and it'll understand what you're, where's my pi? Let me see. Sometimes it'll give me a Greek keyword too. Is my pi here somewhere? Oh, there it is at the bottom. Okay, and then pi over 4. Okay, and you went way over here. What is that? Let's try the other one. Let's try. Still should be 1.707 and pi over. It's not on pi over 4. It says that it is, but it's not. I think it's still referencing rectangular coordinates. Let's see, the x-axis numbers, arrows, braille, reverse. Nope. Arrows, this is the grid, axis numbers, arrows, nope. Okay, x-axis goes from that, y-axis, oh. No, I have it in radians. Okay, if it was in degrees, it'd be completely different. Okay, radians. Yeah, I don't know why it's not labeling that correctly. Let's try a different one real quick. I think it's just trying to reference it in. Let's try one more. Let's see if it'll if it'll label it correctly, the point. I think I would have to translate that point back into you know, rectangular coordinates, unfortunately. Okay. So I think it's only understanding rectangular coordinates right now. So for example, if I did the sine of pi over 2, right? The sine of pi over 2, if I look at my original equation here, if I took the sine of pi over 2, well, that's just 0. 0 plus 1 is 1, so it would be 1, sorry. The sine of pi over 2 is 1, so 1 plus 1 is 2. So it would be 2 and then 0. So again, I think, or 0, 2, sorry. It would be 0, comma 2 would be my rectangular coordinate for that one. 0, comma 2. And again, I think the program is only understanding rectangular coordinates right now. Okay, does that graph correctly? Yeah, I graphed it up there. Okay, on 0, 2. So at pi over 2, at the angle pi over 2, we're getting the correct graph there. Okay, and we could just continue to plot these points. We'll plot a few of them. You can go in and say, oh yeah, just to get an idea. So if we want to sketch this one, okay, if you want to sketch this one, we're going to try various thetas, and then we would do sine of theta, and then we do 1 plus sine of theta, and that would give me my r value, okay, for the radius. And so then I would just have r theta, okay, for these guys. Okay, and so again, 0, if I plug this in, sine of theta is 0, and so this is 1, and so this is 1, 0, okay? If I try pi over 2, okay, this gives me the sine of pi over 2, which is 1. 1 plus 1 is 2, and so this is 2 pi over 2. Okay, if we tried pi over 4, we would get radical 2 over 2, which would be 1 plus radical 2 over 2, which is about 1 point, I'll just do 1 plus radical 2 over 2, which is about, for r, 1.707, and then at pi over 4. Okay, and then so you just continue along. If this is 1, okay, and this is 1, then we're going to start here, right? At 1, at 0, we would start here. Okay, and then we would go all the way to 2 at pi over 2, going through, okay, pi over 4 and 1.707. So we would get, okay, this little arc deal here, okay. And then if we continued along, right, say that we are at 3 pi over 4, okay, or at, let's do, well, 3 pi over 4 would be here, okay. So 3 pi over 4. The sine of 3 pi over 4, that's the exact same thing. It's just radical 2 over 2, and then 1 plus radical 2 over 2. And so this is 1.7073 pi over 4. So we get a mirror image, which is good. And then over here, we were just going to get -1. Well, how do we do that? Well, that's at pi. What happens when we're at pi, right? Well, over here at pi, then the sine of pi is, what are we getting? Sine of pi is 0, and so 1 plus 0 is 1, right? And so then we're back at 1 pi, okay? So not at 110, okay, because we're talking about the angle. Okay, we're at 1 pi. Well, where's 1 pi? We're at pi, but we go out one direction. Positive one direction from the origin. in the direction of pi, right? So that's going to be that value there. Okay. As we move into the third quadrant, okay, if I do say 5 pi over 4, I would get negative radical 2 over 2, right? I would get smaller values than 1. Here we got values that were 1 or larger when it was positive. Why? Because sign was positive. In the first and second quadrant, sign is positive, so I'm going to be adding numbers to 1. Whereas here in the quadrants 3 and 4, sign is negative, so I'm going to be subtracting these values from 1 minus radical 2 over 2. And so this becomes, at 5 pi over 4, which is this direction, at 5 pi over 4, what do I get? I get 1 minus 0.707, which is 0.293. So this is really just a radius of 0.293, very small radius. Okay, and then it's in the direction of 5 pi over 4. We don't go negative like we did in the last one, but we do get these small values. Okay, and then what happens? Well, what happens at 3 pi over 2? This one's kind of interesting, really. Let's do a different color for this one. I want to get my colors all jumbled together here. Okay, so 3 pi over 2. Where's the point going to be for 3 pi over 2? Well, the sign of 3 pi over 2, that's negative 1. What happens when I add 1 to negative 1? Well, it's 0, right? So this is 0. Oh, okay. So r is 0 at 3 pi over 2. Well, does that make sense? 3 pi over 2. Well, yeah, that's where the heart goes in on itself. Okay, on my cardioid. Okay. Okay, so that's where the heart goes in. Okay, on the cardioid. Okay, so the third quadrant creates this little, I don't know. I mean, I think they look like butt cheeks, but who knows? Okay, whatever you want to come up with it. Okay, but where the butt cheeks come together, that's the 0 for the sine function. Okay, so yeah. Okay, and then you just continue along. Okay, continue along, and you get a mirror image. You get this heart, which is called a cardioid. Okay, cardiac arrest, heart arrest. It's Greek for heart. Okay. Okay. Again, all of that for the first hour should have been something that you may have seen in pre-cal. Okay, may not have seen. Let's focus for the rest of the remainder of the day. Let's focus on the calculus part. Okay, because that's when my forte really shines, not in graphing all these things, but analyzing them with calculus. Okay, so how do we find a derivative? Okay, how do we find a derivative in polar coordinates? No, this is still 10.3. Yeah. Yeah, this is just setting up a derivative and a tangent. Okay, so dy dx is equal to dy d theta over dx d theta. Okay, and then I'll spare you the derivation of this. It becomes dr d theta once we plug. Remember, y was equal to r cosine, or sorry, r sine of theta, and x equals r cosine theta. That's where this really comes from. We have to do dy d theta, dx d theta. Okay, and then we have to implicitly differentiate these things. And what we get is we get the chain rule. Okay, maybe we'll show how that works. Okay, so let's see what happens when we do y equals r sine of theta, right? Let's implicitly differentiate this with respect to theta. Okay, let's implicitly differentiate this with respect to theta. So we're going to take the derivative of the first. Well, that's dr d theta, right? That's r with respect to theta. So that's dr d theta times the sine of theta plus, okay, plus what? Plus r times the derivative of sine theta. Well, what's the derivative of sine theta? It's cosine theta. This is r cosine theta, and that's exactly what goes up here in the numerator. It's the r d theta sine theta plus r cosine theta. Okay. And then what's x with respect to theta? Take the derivative of x with respect to, now why do we have to have the dr d theta? Because r is a function of theta. R can be a function of theta. Remember, we had r equals 1 plus sine theta. Well, r is a function of theta, so we have to take the derivative of r with respect to theta. Okay, it just doesn't become a constant or anything like that. It's a function in terms of theta. So we actually have to implicitly differentiate on r as well as with respect to theta. So this is r cosine theta, right? So again, same logic here. Derivative of the first times the second plus the derivative, or plus the first times the derivative of the second. Okay, derivative of cosine is negative sine. So this is going to be a minus r sine theta, and that's exactly what goes in the denominator. Is dr d theta cosine theta minus r sine theta. Okay, so that's our formula to find the derivative. Okay, with respect to r and theta. Okay, we want the derivative or the slope of the tangent line, but in polar coordinates. Okay, so that's how we do that one. Okay, so this is not equals, by the way. This is comma y prime equals and comma x prime equals. Okay, so let's look at example 3 here. Okay, for the cardioid, okay, r equals 1 plus sine of theta. Okay, 1 plus sine of theta. Okay, find the derivative when theta is equal to pi over 3. Okay, so we want to know what's dy dx. Okay, when for r equals 1 plus sine theta. Okay, so r equals 1 plus sine theta, and theta is equal to pi over 3. Okay, so this was dy d theta over dx d theta, which is, I'll just write what it is. This is dr d theta times the sine, times the sine of theta, plus r cosine theta, all over dr d theta times the cosine of theta minus r sine theta. Okay, so that's what that guy is. So what I have to do is I have to figure out, well, what's dr d theta? Dr d theta, that's the only thing that's kind of holding me back here, is I need to know what's dr d theta. Well, that's just the derivative of the polar equation here. Okay, so what's the derivative of 1 plus sine theta? Well, it's 0 plus cosine theta, which is just cosine theta. Oh, okay. So dy dx is equal to, okay, dr d theta, which was cosine theta, sine theta, plus r cosine theta, okay, all over dr d theta, which is cosine theta, plus or minus r sine theta, okay. But what was r? R was 1 plus sine theta. I'd like to get all of this in terms of theta. Why? Because then I can evaluate for the given theta, which is pi over 3. So I'm going to go cosine theta, sine theta, plus 1 plus sine theta. I'm going to replace r with 1 plus sine theta, cosine theta. Okay, and then at the bottom becomes cosine squared theta minus 1 plus sine theta times sine theta. Okay, so this is going to be equal to cosine theta sine theta plus cosine theta. I'm going to distribute the cosine theta plus cosine theta sine theta, okay, all over cosine squared theta minus sine theta plus, or no, minus, sorry, it's a minus, not a plus. So I'm going to distribute the negative too, minus sine squared theta, okay. Okay, so this is equal to, okay, 2 cosine theta sine theta plus cosine theta all over, okay, cosine squared theta minus sine squared theta minus sine theta. Oh, okay. Now, there are some trig identities here that I could use if I really wanted to. But I don't think that's entirely necessary, because all we're going to end up doing is plugging into pi over 3, theta is equal to pi over 3 at some point. We could have even plugged it in way back here if I really wanted to. Okay, at some point I just have to plug in. I cleaned it up algebraically a little bit. Okay, if I really wanted to, I could. You know. But then what we do is we get into some double angle formulas. I believe that sine 2 theta is equal to the 2 cosine theta sine theta, and cosine 2 theta is the cosine squared. Pretty sure that's what that is. Let me look it up in my trig here. Yeah, they're the double angle formulas. So yeah, 2 sine x cosine x is sine. Again, so at any point here you can plug in these angles. Let's see if it comes out any nicer if we do this. Sine 2 theta plus cosine theta all over, and cosine squared minus sine squared, that's cosine 2 theta minus sine theta. Okay, so we get all the way to there if we really wanted to. And let's plug in pi over 3 and see what we get here. Okay. Did you have a comment? No? Okay. Okay, so we're going to go sine of 2 pi over 3 plus the cosine of, okay, sine 2 pi plus cosine of pi over 3. Okay, so all over the cosine of 2 pi over 3 minus the sine of pi over 3. Minus the sine of pi over 3. Okay, so let's see what this equals. The sine of 2 pi over 3, remember that's our unit circle, right? And we're at 2 pi over 3. So the sine of 2 pi over 3, that's going to be my positive, because the y value is the sine, that's positive radical 3 over 2. Okay, cosine of pi over 3, the cosine of pi over 3, that's going to be my 1/2, I believe. Okay. Okay. Cosine is the x's, yeah. 1/2. Okay. Okay. What about cosine of 2 pi over 3? Well, what's cosine of 2 pi over 3? Well, that's going to be negative 1/2. And what's the sine of pi over 3? Well, that's going to be, this is minus radical 3 over 2. Now notice that the top is just the negation of the bottom. And so if I really wanted to factor out a negative from the bottom, I would just get top and bottom be the same thing, and this would come out to be negative 1. Okay, so we know that dy dx, okay, the derivative of for the derivative at pi over 3, okay, the derivative of the function, okay, on this cardioid at pi over 3, okay, the slope of the tangent line at pi over 3 is equal to negative 1. Now let's take a look at that. that real quick. So dy dx is equal to -1 for theta equaling pi over 3. Okay, so let's see if I have my Desmos up here still. I do. Okay, so at pi over 3, it's looking like, let's see if I can work it so that I can get that value there. Okay, I will have to translate this into polar coordinates, or sorry, into rectangular coordinates, because Desmos does not like polar coordinates. So let's do that real quick. Let's see what happens at pi over 3. So r is equal to 1 plus sine of pi over 3, right? So we have our r theta, but I don't really want that. I want x. Okay, x is equal to r sine of theta, right? R sine of theta. Okay, let me think about this for a second. Okay, I want to translate it into here. Give me an r and a theta, and yeah, r is equal to 1 plus sine theta, right? Okay, give me an r and a theta. So this is going to be 1 plus sine theta times sine theta, right, for x, or sorry, this is for y, my bad, for y, okay, that's the sine theta, 1 plus sine theta, okay, and, okay, and so, think about this for a second. So the x value at pi over 3, okay, so this is going to be 1 plus radical 3 over 2 times radical 3 over 2. That's going to get really, so distribute, right? So this is equal to radical 3 over 2 plus, well, the radical 3 times the radical 3 becomes 3, and this is just 3/4. So that would be my y value, okay, for theta equals pi over 3. Okay, what about my x value? My x value is equal to r cosine theta, which is 1 plus sine theta. That's my r, which is my graph, is my equation in polar, times cosine theta, right? So this is equal to, again, 1 plus radical 3 over 2. Again, for theta equals pi over 3, okay? Sine of pi over 3, okay, is radical 3 over 2. Okay, and the cosine is 1/2. So here I'm going to distribute the 1/2 this time. This is 1/2 plus radical 3 over 4. Okay, so 1/2 plus radical 3 over 4, that's my x. So if I were to plug this into rectangular coordinates, 1/2 plus radical 3 over 4, comma, radical 3 over 2 plus 3/4. So maybe I'll rewrite that, okay, as 3/4 plus radical 3 over 2. Okay, so let's see if Desmos likes this or not. I don't know. Let's see. 1/2 plus radical 3 over 4. So I'm going to do my parentheses. 1/2. Nope, go back. Okay, my backspace, there it is. Okay, 1/2 plus radical 3. Radical 3. My radical 3 over, nope. Radical 3 divided by 4. Okay, and then let's do our comma, okay, and then, what was the other one? 3/4 plus radical 3 over 2. Okay, 3/4 plus radical 3 over 2, comma, 3/4, what the heck, man? Why did it close my parentheses? Okay, 3/4 plus radical 3 over 2, I believe, plus radical 3 over 2. Boom, right there. There's our black point. Okay, so it worked. It's on radical 3 over 2. Okay, or sorry, pi over 3. It's on pi over 3. Okay, and so what it's saying is it's saying that the equation of the tangent line here, the equation of the tangent line will have a slope of -1. So if I don't know if this thing has a ruler or not. I don't know. Okay, but let me go back to my diagram. It's saying that the derivative at this is -1. Okay, so if we go back to my lovely diagram, okay, of the cardioid. Where was the cardioid? Right? So it was, yeah, it was this cardioid. Okay, it's saying that here, okay, at this point, the slope, okay, is -1. Okay, that's dy dx equals -1. Now, let's actually find what that tangent line is. We know what the slope is, and we have a point. We have a point, and we have a slope. So we could use point slope form to actually get what this is, right? So where was the point? The point was here, okay. And so let's get that. Let's find the equation of the tangent. Let's make that number 4 here. Find the equation of the tangent line to r equals 1 plus sine of theta at theta equals pi over 3. Okay, theta is equal to pi over 3. Okay, so hopefully you guys have taken trig or had some trigonometry. Okay, this is where we live. We live in this area for a long time in Calc 3. So, you know, if you're really good at this polar coordinates, you'll do fine in Calc 3. Okay. Find the equation of the tangent line to r equals 1 plus sine theta at theta equals pi over 3. Okay, so what do we have? We had a point, and we have the slope, right? So we had dy dx equal to -1, and then we had this point, y x sub 1, y sub 1, right? And that, so I'm going to say, okay. Okay, so y minus y1 equals x, or m, sorry, m times x minus x1. Okay, so what is y1? Well, it's what we just found out. It's this point that we found was in rectangular coordinates for our cardioid. Okay, at pi over 3. So that's going to be y minus 3/4 plus radical 3 over 2 is equal to m. Well, what was m? M is the slope, which we found was -1, times x minus, okay, the x value, which was 1/2 plus radical 3 over 4. Okay. So now let's just clean this up. Okay, so this is a negative x. This is going to be plus, when I distribute that. Okay, plus 1/2 plus radical 3 over 4. Okay, and then I could add this thing to both sides, right? Add 3/4 plus radical 3 over 2 to both sides. So 3/4 plus radical 3 over 2. Okay, add that to both sides. That cancels. I'm left with y equals -x. 1/2 plus 3/4, that's 1/2 is 2/4, right? So this is 2/4. Okay, 2/4 plus 3/4 is 5/4. So this is going to be plus 5/4. Okay, plus what? Well, this is radical 3 over 4. This is going to be 2 radical 3 over 4. Just multiply top and bottom by 2. And we get 3 radical 3s over 4. Oh, okay. And so this is y equals -x plus 5 plus 3 radical 3 all over 4. Okay, so what's the slope? Slope is -1. What's the y-intercept? Oh, it's this kind of weird number here. 5 plus 3 radical 3 over 4. Okay. So let's see. Let's go back to Desmos. Let's plot this real quick. Okay, let's plot this line real quick. Okay, so y equals. Okay, see if it doesn't work. Y. Would you stop with the editing tips? How can I turn this stupid thing off? I do not want the editing tips. Turn off the editing tips. Goodbye. I know how to edit this thing. Okay, y equals. Okay, what do we say? Negative x. So negative x. Okay, y equals negative x. Okay, that's negative x. Okay, right there. But what we have to do is we have to change the y-intercept. Okay, so plus y equals negative x plus, and where's the y-intercept go? It goes to this funky point. 5 plus radical 3 over 3 over 4. Okay, so plus, okay, 5. Actually, I'm going to put this in parentheses. Okay, 5 plus 3 radical 3. Okay, close parentheses. Over 4. Over 4. Boom! Look at that. Does it does in fact go through my point, and it is tangent at the point. Okay, and that not only is that the angle, that's the angle, right? That's the angle pi over 3. Okay, that's the angle theta is pi over 3, and it's the slope, and okay, and the y-intercept is up here somewhere. Okay, 0, 2.49. Okay, that's the y-intercept, and it's on. So good. It all works out in the end. Okay.
Professor, can I ask you a question?
Yeah, go ahead.
So on the next, like tomorrow in the quiz, we will have something like this on the quiz?
You will have a graph. You'll have an equation. You'll have to identify the graph. Okay. Or some other things. More of finding the derivatives, and then more of what we're going to be going into now. You're going to be doing arc lengths in rectangular coordinates, which was 8.1. And you're going to be doing arc lengths in polar coordinates. So not finding the tangent line so much like we did here, but know how to go from rectangular to polar and polar to rectangular. Know how to find the equation of a polar equation as a rectangular equation. A lot of those things. So
yeah.
You'll have.
So the most important thing that I should get is like how to transfer from like the rectangular points to polar.
Yeah.
This is the most point that I should get from this chapter.
Is the quiz more slanted toward chapter 8? No, actually it's not, I don't think. I mean, there is arc length, there's 10 questions. I mean, it's about half and half, so it's pretty balanced. Okay, let's see what else we got here. Yeah, that's about it for that guy. Actually, I do need Desmos. Let me see if Desmos will do the thetas. Let me think about this for a second. Well, if I do the thetas, okay, will it? Okay, if I go to my polar coordinates, okay, and I go away, and I say I want say r is equal to r is equal to 2. Oh, okay. R is equal to 2. See if it'll do that for me. So R is equal to 2. R is equal to 2. It should just give me a circle, a rate of, yeah. So R is equal to 2. That's a circle. Okay. That's a circle of radius 2. Right. Okay. So that's good. Okay. If I just plug in an R, it'll do that. That's fine. And what about theta? If I do theta equals pi over 3, what do you think that's going to be? Theta equals pi over 3. That's good. Divided by. Come on, knock it off. Go back to the regular keyboard. Oops. Theta is equal to just a pi over 3. Well, that should just be a line, right? Just want to make sure that this works. Theta equals pi over 3. I'm just going to type pi over 3. Okay. And hit enter. Oh, it didn't like it. It did not like that. It doesn't like the theta equals pi over 3. Okay, makes sense. Okay, so it's a little bit limited in what it'll do. Okay, but gives you the basic ideas. Okay, let's move into 10.4. Okay, and that is arc length. Okay, arc lengths and areas in polar coordinates. Okay, sector areas and arc lengths in polar coordinates. The pen go. Oh, there it is. Okay. Okay, so 10.4. Okay, areas and lengths in polar coordinates. Okay, areas and lengths in polar coordinates. Okay, let's look at what a sector area is. Again, this is a lot of trigonometry, but a lot of trig review here. A sector area. What's a sector? A sector is a piece of a circle. Okay, it's like a piece of a pie. Okay, that's a sector. Okay, and so how do I find the area of a sector in terms of r and theta? Well, the area is equal to 1/2 theta, okay, times r squared. Now, does that make sense? Well, what's the area of a circle? Well, the area of a circle is pi r squared, right? So, and what's the area of the whole circle? Isn't that, what's the area of the whole circle is pi r squared. What's the angle of the whole circle? Well, the angle of the whole circle is 2 pi. So if I plug in 2 pi here, okay, not to be confused with 2pog, which is a wrapper, 2 pi, okay, you divide 2 pi times 1/2, and that gives me just pi r squared, which would make sense. So you take the angle in radians, cut it in half, and that will give you the sector area, okay, the piece of the pie that you're looking for. Okay, so in polar coordinates, if I want to find an area of a polar equation, then the area, okay, is approximately equal to, okay, the sum as I equals 1 to n of 1/2 of all of these, you know, all of the, which is basically r. Okay, you can think of r and f theta as a function of theta, and r to be the same thing. Okay, and I'm going to take those values, I'm going to square them, and then I'm going to take these little incremental thetas, or what we call d theta. Okay, or delta theta. We'll do delta theta because it's a sum. Okay, delta theta. And so, okay, we let our delta theta go to 0, the limit of this thing go to 0, then we have the integral, okay, from a to b of 1/2 of r, which is our f of theta, squared, okay, d theta. Okay, d theta just means we're working with an infinitesimal, where your delta thetas go to 0. Okay. So, and again, if you want to think of it as in terms of r theta, you can. This is just a to b of 1/2 of r theta, r of theta, or just r. Okay, just know that r is not a constant here. R is a function of theta. Okay, squared d theta. Okay, so that's our formula to find the area of what we call a sector. Okay, this was squared, by the way. Okay, the area of a sector. Okay, you could pull the 1/2 out in front if you really wanted to. Okay, so we're going to use this, okay, to find a sector area. Find the area of one loop of the 4-leaf rows r equals cosine of 2 theta. Okay, so r equals cosine of 2 theta. So what does r equal cosine 2 theta look? What does this thing look like? Instead of plotting it all by hand over and over again. Okay, let's see what this thing, why they call it a 4-leaf rows. But let's just verify it does this real quick. Okay, so I'm gonna just go down. I'm gonna do the, Frederick gave me a good hint on this here. R equals 2, or sorry, cosine of 2, and then I'm just gonna type in theta, and it gives me theta. That's good. Okay, and look at that, 4 petals on this. Okay, and we start. Okay, we start right at 1 here. Okay, why? Because at 0, cosine of 0 is 1. So we start out at 1, and then I don't know if you can see. I can't really write on this either. Let me think. Annotate. How do I annotate? Spotlight. Can I spot? I don't know. Maybe not. Draw. Can I draw on it? Can I draw on this screen? Oh, I can. Hey, let's erase this. Eraser. You're not erasing, dude. Testing. Oh, it crashed. It crashed. 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 It crashed. It crashed. Got too hot. Well, that kind of sucks. As well.